So I've been working on making my game feel a little bit more cyberpunk. And it struck me, do you know what scream dystopian future? Cables. Cables everywhere. First, I tried to create a couple of cables in Blender and I imported them in my game and I rotated and scaled them to fit different location. But that was really annoying to do and it took a really long time and it didn't even look that good. So I started thinking, I wonder how hard it is to dynamically create cables. I should not have said that. But after asking ChatGPT, it told me that this actually has a name. It's called a Catenary curve, and there's even a Wikipedia article about it. Now, usually I need someone to explain to me the formulas on Wikipedia, but this one is actually fairly simple. It's simply a multiplied by cos h of x over a. And the a is just what I would call the droopiness factor. So to generate a cable, you can imagine just taking 5 or 6 points on that curve and creating cylinder mesh between each of those points. And the more points you use, the smoother you're going to get a cable. Godot even has a primitive cylinder mesh that you could use and just orient between the 2 points, and it would probably do the job. But we can do a little bit better than that at the intersection by generating our own mesh. What we want to do is basically explode each point around our catenary line to a radius r, and the radius is going to be the size of our cable. Of course, you can't get a perfect circle in computer graphics, so we have to pick a number of sides. If we say we want 5 sides for our cylinder, we can divide the circle 360 degrees by 5 and get 72 degrees between each vertices. And then with sin and cos, you can get the vertices position. Now you always want to keep these vertices on a 2D plane, but in 3D, this 2D plane could have any number of orientation. And if you don't choose the orientation right, you can end up with very weird looking crooked cylinders. But what is the ideal orientation? Well, the orientation is basically what is perpendicular to the tangent of your curve. And that sounds complicated because normally it involves, derivative and integrals and stuff. But we've already simplified our curve into line segments. And so in this case, we can use a nice little trick because the derivative of our point that will give us the tangent is basically just the direction between the previous point and the next point. And if we use that and normalize it, we get the tangent. And by using the cross product, we can get the normal and the binormal, which are basically going to be the points that lie on the circle we want to create. Once you have all the vertices for all the points on your catenary line, you can use this to generate the mesh by passing the indices that will create the triangle strips for your mesh to the add surface from arrays Godot function that will return a mesh that you can assign to a basic mesh instance 3D node. And now we can create a nice long tube from any part of our catenary line. But that's where it gets tricky because we don't want any random part of our catenary line. We want specifically the part that connects 2 points in 3D space. But what does that mean exactly? Because the catenary line is a 2D thing. It never wobbles in 3D. So, okay, even if I remove one dimension, say I set the Z to 0 on all my 3D points, so now I'm working on a plane. What does that mean to connect 2 random points on the screen to my catenary line? Instinctively, it feels like there's some kind of relationship because if I move my catenary graph on top of 2 random points on the screen, they only ever seem to intersect in one specific part of the line. But even when I asked ChatGPT how to solve this, it gave me like bogus code that didn't work at all. And so I turned to the internets, and there's a couple of really nice websites discussing different solutions. But that's where I hit my first major snag. Most of these websites describes the easy solution where both points are at the same height. That's because if you do that, the solution becomes relatively simple to calculate. But if you want points that can be at different heights, then it gets complicated. Wikipedia calls it a transcendental function that needs to be solved numerically, which, for people who don't speak Wikipedia, that means that you have to search for the answer. There's no easy way to calculate it. So that sent me down another rabbit hole of how to do this in a program. And it didn't even really solve the initial question, which was, how do I apply this to my catenary curve? I spent days trying different solutions and they never quite worked until it finally clicked in my head. I don't care about the position of the 2 point. What I care about is the distance and the difference in height between the start and the end. And if I think about it like that, then it doesn't matter where my 2 points are. I can just put the first point at 0, 0, and then walk the x until I find the y I'm looking for. And the way I do it is as straightforward as I can do it. I walk 1 meter at a time until I find what I'm looking for. Then I start going back by smaller increment until I cross the threshold of what I'm looking for. Then I go forward again and then back again and forward again as many times as I need to get the precision I want. And in reality, since I'm dealing with meters here, after just 4 iterations, I'm already in sub-millimeter precision, which is plenty enough for my use case. And since I'm not planning to have like 1,000-kilometer long cable or something, in reality, I find my solution in like 10 or 20 steps or something, which is really not that bad. So the very last thing I need to do with this cable is to apply some material to it. And I'm not going for anything fancy here. I don't need to apply texture or do any kind of UV unwrapping. I just want one single color. And I could create a material in Godot and just set the albedo, but my game is already using some kind of palette texture PBR thing that was created by another YouTuber called Infinzia. And so I can just set the UV of my cable to a coordinate in that palette texture, and I can have any kind of plastic or metal or even glowing cable. And that just kind of works. To make things a little bit easier to use, I threw everything into a tool scripts, and then I exposed a couple of export variables for the number of segments, the number of sides, the UVs I want to use, and the droopiness factor. And to make it refresh in the editor, I created setters and getters for all of those export variables, and I used the engine.isEditor hint to make sure that this only happens in the editor. So when the game is running, it all gets created at load time and never touched again. So it's fairly efficient. Plus, if I need to batch things together, it's possible because they're all the same material. And if I need to improve the loading time, I can always revisit the algorithm I'm using to generate everything. And with this, I had everything I needed to quickly place a bunch of cable everywhere in my scene, color them any color I want, and honestly, it was pretty nice to use. Now, I'm a solo indie developer, so I don't need it to be perfect, but there are a bunch of things I would improve if I needed this for like a bigger project or something. First, like selecting the UVs is kind of awkward because I have to manually input the UV coordinate. I wish I could pick them from inside the texture or something, but I don't know a way to do that in the editor in Godot. If you know, do leave a comment below because this is the biggest pain point I have right now. Also, if I was a clever person, I would use a much better algorithm to solve my catenary equation because right now it's like 20, 30 iterations for each curve I have to solve. If I have hundreds of cable in my game, that could significantly increase the loading time. But for now, it's not a major issue. I can even imagine pushing things even further. If I was working for a big studio, I could imagine like actually properly UV unwrapping my cylinders so that you can apply any kind of texture you want to it and use it for like big tube stuff or big cables. And you could even make away with cylinders and generate any kind of mesh you want that repeats, so you could make trains or actual bridges or something. But that's way beyond what I need for my little solo indie project. For what I need right now, this is just perfect, and it works pretty well. I can create any colors I want, red and blue cables for my bombs, anything is fine. And that's gonna be it for this week. See you all in my next episode. Bye!